Hi everyone, I hope all of my viewers are doing great. I am Nikita Vallabh, an NSC Data Science student. I welcome you all for this presentation, which is about the fundamental concept of natural language processing. So today we are going to talk about something really important in the world of language and technology. It's called semantic analysis. In a simple statement, I could say it as it helps computers to understand what we mean when we use words and sentences. Imagine you are talking to a chatbot or using a translation app. Of course, machines are not as much capable as of humans to correctly rectify or understand the statement or any query. That's where semantic analysis comes into play. It helps these tools to figure out the real meaning behind the words you are using, making them more helpful and accurate. It's basically like reading between the lines of written language, such as any sort of text messages or articles. It helps us to figure out the hidden meaning, like the overall context, emotions, and opinions, even when the information is not neatly organized. Well, I must not blame machines because humans are also sometimes incapable of doing an accurate semantic analysis. In this presentation, we will break down what semantic analysis is. I will show you how it works, what are all the techniques and the various machine learning tools involved for semantic analysis. And next, we will delve into its examples and applications up till this date. So let's take a journey together through the world of semantic analysis in natural language processing. Let's begin by understanding what semantic analysis is all about. In simple terms, it's the art of making sense of text. It's like giving computers the ability to unravel not just the words on a page, but also the context, emotions, and underlying meaning within the messy and complex data. In a sense, it empowers machines to understand language in documents, reports, and various forms of written communication. Now that we know what semantic analysis aims to achieve, let's explore its essential components. The first essential component being the sentence structure and the word connections. At its core, semantic analysis examines how sentences are structured and how words are interconnected to each other. It's like dissecting the building blocks of language to grasp how they fit together. The second next essential component being meaning and context. It goes beyond just recognizing individual words. It unravels the meaning and context within the sentences. It's like revealing the nuances and implications of what's being said. Semantic analysis is not a standalone concept. It's a vital component of natural language processing, a field that's all about enabling computers to understand and interact with human language. Moreover, it plays a significant role in modern machine learning, where it empowers algorithms to process and interpret text-based data, making them smarter and more responsive. As we all have seen previously, semantic analysis begins its journey by simply first grasping the meaning of individual words. Well, this reliance is known as lexical semantics. Think of it as understanding the unique essence of each word in a sentence. However, semantic analysis doesn't stop there. It goes deeper, meticulously examining how words are interrelated, providing valuable context. This deep dive into word relationships is what truly enriches the understanding of any language. Now, let's shed light on the tangible impact of semantic analysis on our everyday lives. Drive applications like semantic analysis fuels the applications that touches our life in more ways than we often realize, from sorting our emails to analyzing reports and even accessing the sentiments behind customer review. It's at the heart of various tools and technologies we rely on daily. Beyond emails and customer review, the power of semantic analysis transcends industries. It's a key player in the extraction and interpretation of data across sectors, whether it's healthcare, finance, or marketing. Semantic analysis provides the intelligence needed to make sense of vast amount of textual information. I hope everyone has received a brief structure about what semantic analysis is. Now moving on towards the next part of this presentation, which shows that how semantic analysis is highly beneficial for the customer service department of any company. It shows that how semantic analysis helps the customers as the technology enhances the overall customer experience at different levels. Let's understand these key advantages in detail, starting with gaining customer insights. Semantic analysis helps in processing customer queries and understanding their meaning, thereby allowing an organization to understand the customer's inclination. Moreover, the analysis of customer reviews, the feedbacks, or the satisfaction surveys helps understand the overall customer experience by factoring in language tone, emotions, and even sentiments. After gaining customer insights, the obvious goal is of company's performance. Well, the automated semantic analysis allows the customer service teams to focus on complex customer inquiries that requires human interventions and understanding, where the machine can analyze the messages received on social media platforms, chatbots, and emails. Well, this improves the overall productivity of employees as the tech frees them from the mundane task of answering simple queries or simply understanding a statement which a machine can handle by itself, and it allows the employees to rather concentrate on the critical inquiries or the operations. The last but not the least is how semantic analysis helps fine-tuning the search engine optimization strategy by allowing companies to analyze and decode users' searches. All of us are using Google to search for something or other. Well, semantic analysis helps Google to understand what you're looking for, so it can show you the right websites. It's like having a helpful friend who knows exactly where to find your favorite toys. User search analysis, it's like Google knowing what you want before you even finish typing. And the optimized content delivery, it helps the websites to show you the best stuff when you search. It's like getting the most delicious ice cream when you ask for it. So there you have it. Semantic analysis, it's like having a super smart helper that makes things easier for companies and helps you find what you need online. It's like all about making life simpler and better for everyone. Let's have a look on the technical aspects of semantic analysis in simple terms. Starting with having a data, the obvious next step would be data processing. This is like preparing the ingredients before cooking. In semantic analysis, it means getting the text or information ready to work with. The next is defining features, parameters, and characteristics of processed data. Think of this like picking the important part of the recipe. In semantic analysis, we decide what details are crucial to understand the text, like finding the main ingredients in a recipe. The next step is data representation. Imagine turning the words into pictures or symbols. In semantic analysis, it means changing words and sentences into a format that computer can understand easily. The next part is defining grammar for data analysis. This is like setting rules for a game. In semantic analysis, it means creating guidelines for how the data should be examined, like deciding the rules for a game to make it fair. The fifth step would be accessing semantic layers of processed data. Picture a sandwich with different layers. In semantic analysis, we look at the different meaning or parts of the text, like examining each layer of a sandwich separately. The last being the performing semantic analysis, the performance of semantic analysis based on linguistic formalism. Think of this as following a recipe step by step. In semantic analysis, we use a structured approach to understand the text, like carefully following the steps in a recipe to make a tasty dish. So, the overall concept is semantic analysis involves getting data ready, picking out the important part, turning it into a computer-friendly format, setting rules, examining different meanings, and following a structured approach to understand language better. Here is a pictorial representation of how data is being processed. Starting with the source program, the data is transferred into lexical analyzer. As we have already seen about lexical semantics, which extracts the individual meaning of each word in a particular context. At, After this, the data is moved on to the parser, which basically assigns the grammatical rule to each word and also helps to resolve the ambiguity in words having multiple meanings. Let's have a detailed view on this analyzer in step 3. When a computer analyzes text, it needs to figure out the meaning of words. Sometimes a word can mean different things. For example, blackberry could mean a fruit or a company's product. To understand what a word means in a sentence, the computer looks at the words around it. This is like looking at the environment or situation in which the word is used. For example, let's take a sentence. Blackberry is known for its sweet taste. It's clear that we are talking about the fruit, but in the next statement, I got a blackberry. It could be a fruit or a product from the company. So the computer uses context or the surrounding words to figure out the right meaning for the whole sentence or language. This helps artificial intelligence algorithms to understand what we are saying more accurately. Let's just dive into some of the critical elements of semantic analysis. There are 6 critical elements of semantic analysis. Let's have a quick exploration to it. The first one is polysemy. This is when a word has multiple meanings, but all those meanings are related and are found in one dictionary entry. For example, dish can mean a type of plate or a course of food. Both meanings are related to the idea of dish. The second one is hyponyms. This is like saying that specific words are related to more general words. For example, red, blue, and green are all types of colors. So, color is the more general word, which is known as hypernym, and the specific color are the hyponyms. The third element is meronymy. Think of this as talking about the smaller parts of something. For instance, mango is a part of a mango tree. So, mango is a meronymy of the tree. The fourth critical element is homonyms. These are words that have the same spelling and pronunciation, but mean completely different things. For example, bulk can mean the sound a dog makes or the outer covering of a tree. Despite looking and sounding the same, they have different meanings. The next step is synonyms. These are words that have similar meanings. For example, abstract and summary are synonyms because they both convey the idea of summarizing something. And the last element is antonyms. These are words with opposite meanings. For example, cold means the opposite of warm or hot. Up till now, we have seen a lot about what semantic analysis is, how it works, about its elements, about lexical semantics. Let's now have a look into the machine learning algorithms. We can actually assist machines in getting pretty good remarkably at making accurate predictions. How do we do it? Well, we show them text, lots of it. They learn from this text and then they apply that learning to make smart guesses. It's kind of like when you learn from experience. These guesses, they are not random. They are based on things the machine has seen before, like recognizing familiar patterns in the information. Now, in this whole machine learning deal, especially when we are talking about language, there are some other tasks involved. Things like figuring out how different parts of the text are connected to each other and making sure the machines understand which meaning of a word fits best in a sentence. It's all about helping the machine to really get proficient at understanding and using language effectively. Let's just dive into this task a bit more and see how they work. In the world of semantic analysis, there is this clever process called word sense disambiguation. It's like the brain of a computer trying to figure out based on how it's used. Let's take an example, Raspberry Pi. For instance, it could mean a tasty fruit, a small computer, or even a UK-based foundation. Many more examples are shown in this picture presented. Let's take the word plant, whether it's the green plant outside in our gardens or the workplace. The word bank, whether it's a financial institution or a river bank. So it's pretty important to pinpoint which meaning makes sense in a sentence. That's what word sense disambiguation is all about, making sure the computer gets it right. The next algorithm is about relationship extraction. In the world of semantic analysis, it's like playing matchmaker for words in a sentence. It's all about figuring out how different words are connected to each other and what roles they play. Think of it like a puzzle where you identify various things like people's name, place, companies, or job titles, and then connect them with categories like is the chairman of or main branch located at. Let's just discuss this with an example. Let's take a sentence which says like Elon Musk is one of the co-founders of Tesla, which is based in Austin, Texas. Here we have two different relationships. First, Elon Musk is connected to Tesla, which is a company, and second, Tesla is linked to Austin, Texas, which is a place. Relationship extraction helps us to make these connections and understand how things relate in a sentence. It's like being a language detective, uncovering the who, what, and where in the story. Finally, let's just end up this entire presentation about semantic analysis by looking onto the top 5 applications of it. The first application, of course, the most famous and commonly used natural language processing tool, the conversational chatbots. Chatbots are like helpful talking robots that many companies use. They are super smart because they understand the meaning of words and can have a conversation with people. These chatbots are great at solving problems and make customers happy quickly. They can help with things like shipping, answering questions, and giving personalized advices. Some chatbots are even really good at figuring out how people are feeling by listening to their words and can respond in a way that matches those feelings. So, in the end, chatbots save time and money by using semantic analysis to understand what users want and help them faster. Next application is automated ticketing support. As we have discussed earlier about how semantic analysis works on customer support. It's just a same technique over here. When people send any request or problems like IT issues or legal questions, the system reads the messages and understands what they are talking about. Then it sends those requests to the people or departments who can help, like the IT help desk or legal team. That's how providing customers quick and accurate answers to their problems. Plus, if something is really urgent, the system can flag it and make sure it gets to the right team right away. So, semantic analysis helps make sure everyone's question and issues are taken care of promptly. Semantic analysis builds a new block for the companies in helping them grasping the emotions behind what customers say online in the form of sentiment analysis. Imagine it's a kind of emotional radar that detects whether people are happy, unhappy, or somewhere in between when they write reviews or comments on the internet. This insights allows companies to make customers even happier, addresses their concerns, and fine-tune their marketing strategies. We all are very well familiar with this application. Semantic analysis is like having a smart assistant that knows your intent while searching. Have you ever noticed how when you start typing a search in Google, it suggests what you might be looking for? That's search autocomplete. It saves time because you can simply click on the suggestion drop-down box. Uh, for online stores or the online applications that we are using, there is a smart search that watches what you do on your website and shows you things you are interested in buying. That's the things on your wish list or on your recent views. That's how company make their strategies of enhancing their profits. Last but not least are the language translators. These tools are enhancing day by day. They have become really smart, all thanks to something called semantic analysis. In the past, tools like Google Translate only did word for word translation. But now, with fancy technology like natural language processing and deep learning, these tools can understand what you actually mean and not just the words you type. They look at the sentences and the situation to give you a better translation. So, if you are trying to say something in other language, it's more accurate and helpful than before. Welcome you all to the era of data explosions. To thrive, we need to make sense of this treasure trove of information. Semantic analysis is our secret weapon. It helps us to understand the meaning behind the text and extract the gold from unstructured data. It's the magic in our machine learning tools, boosting